emergency landings, technical diversions, and cockpit alerts. These phrases have become alarmingly common in aviation news throughout 2025 and into 2026. What was once considered rare is now happening with disturbing frequency across airports worldwide. Just this spring, on April 6th, Swiss flight LX325 declared an emergency over Belgium following an unusual smell and possible fire indication in the forward galley that forced an unscheduled landing. That same week, multiple airlines across Europe reported precautionary diversions due to various technical issues. And this isn't isolated to one region or one airline. The International Air Transport Association's latest safety report reveals a troubling trend. Fatal accidents and onboard fatalities increased in 2025 compared to the previous year. These aren't just statistics on a spreadsheet. These are real flights carrying real passengers who trusted that their journey would end safely at their destination. But here's what most passengers don't realize. The aircraft themselves aren't the problem. Modern commercial jets like the Boeing 787 and Airbus A350 are engineering marvels with multiple backup systems and decades of safety improvements built into every component. So why are we seeing more incidents now than we have in years? The answer lies not in the skies, but in the invisible systems that keep airlines running on the ground. To understand what's happening, you need to know how airline safety actually works. Every flight you've ever taken relies on thousands of decisions made before the aircraft ever leaves the gate. Maintenance schedules, crew assignments, weather analysis, fuel calculations, route planning, and real-time monitoring systems all work together to ensure safe operations. For decades, this system worked because air travel was simpler. Fewer flights, less data to process, and more time between decisions. Airlines could rely on legacy computer systems that were designed in the 1980s and 1990s to handle what seemed like massive amounts of information at the time. But the aviation landscape has changed dramatically. Airlines now operate in an environment where a single flight generates more data in one trip than entire fleets produced in a month just 20 years ago. Every sensor reading, every radio communication, every maintenance check, and every weather update creates digital records that must be analyzed, stored, and acted upon. Clinton Cardozo, CEO of aviation software provider OneReg, has been watching this transformation from inside the industry. His company works directly with airlines to manage compliance and safety systems, giving him a front-row seat to what's really happening behind the scenes. According to Cardozo, airlines are operating under intense pressure where even isolated incidents attract massive scrutiny from regulators, media, and the public. The recent cluster of emergency landings and technical diversions shows how quickly operational pressure can build when systems aren't equipped to handle the volume and speed of modern aviation data. The numbers tell the story. A typical wide-body aircraft today has over 50 computers monitoring everything from engine performance to cabin pressure. Each computer generates thousands of data points per flight. Multiply that by the fact that major airlines operate hundreds of flights daily, and you're looking at millions of data points that need to be processed, analyzed, and acted upon in real time. Legacy systems that airlines have been using for decades simply weren't designed for this volume. They were built for a simpler time when a maintenance alert could wait until the next scheduled check, and when flight operations centers had hours to analyze weather patterns instead of minutes. But today's aviation environment demands instant responses. When an engine sensor detects an anomaly over the Atlantic Ocean, that information needs to be transmitted to ground control, analyzed by maintenance teams, cross-referenced with historical data, and acted upon before the aircraft reaches its destination. Any delay in this process can turn a minor technical issue into an emergency landing. The Swiss flight incident over Belgium is a perfect example. Flight LX325 was operating normally when a technical alert appeared in the cockpit. In previous decades, the crew might have continued to their destination and addressed the issue during a scheduled maintenance check. But modern safety protocols require immediate action when certain alerts appear, even if the aircraft is still flying normally. The pilots declared an emergency, diverted to the nearest suitable airport, and landed safely. From a safety perspective, this was exactly the right response. But from an operational perspective, it created a cascade of complications. Passengers had to be rebooked, crew schedules were disrupted, gate assignments at multiple airports had to be changed, and maintenance teams had to be dispatched to an unplanned location. This single incident required coordination between air traffic control in multiple countries, airport operations teams, airline dispatch centers, maintenance crews, and customer service departments. Each of these groups was working with different computer systems that weren't designed to communicate with each other seamlessly. The winter season of 2025 and 2026 has been particularly challenging because multiple factors have converged simultaneously. Supply chain constraints mean that replacement parts for aircraft take longer to obtain, forcing airlines to keep planes in service longer between major maintenance checks. Meanwhile, the aviation industry is still recovering from the massive disruptions of the early 2020s. Many experienced mechanics and technicians left the industry during that period, creating knowledge gaps that are only now becoming apparent. Newer employees, while well-trained, don't have the institutional memory that comes from decades of experience troubleshooting complex systems. Weather patterns have also become more unpredictable, forcing more frequent route changes and altitude adjustments that stress both aircraft systems and operational planning. Climate change has created weather phenomena that challenge traditional forecasting models, making it harder for airlines to plan for contingencies. All of these factors feed into the same bottleneck: outdated digital infrastructure that can't process information fast enough to support real-time decision-making. When a technical issue arises, maintenance teams need instant access to historical data about that specific aircraft, parts availability at potential diversion airports, crew duty time regulations, passenger connection requirements, and dozens of other factors. In the old system, this analysis might take hours. But when you're dealing with an aircraft carrying 300 passengers flying at 35,000 feet, hours aren't available. Decisions need to be made in minutes, and the systems that support those decisions are struggling to keep up. Cardozo points out that what we're seeing is a sign that the industry's digital foundations need to evolve. Today's incidents generate far more data, require faster analysis, and demand clearer documentation than archaic compliance networks were ever designed to handle. Airlines that continue to rely on outdated technology are finding themselves increasingly unable to respond effectively to operational challenges. The solution isn't simple, and it isn't cheap. Airlines need to invest in integrated real-time compliance platforms that can process massive amounts of data instantly and provide actionable insights to decision-makers. These systems need to communicate seamlessly with air traffic control, maintenance providers, airport operations, and regulatory agencies. Some airlines have already begun this transition. They're implementing artificial intelligence systems that can predict maintenance issues before they become critical, optimize flight routes in real time based on weather and air traffic conditions, and automatically coordinate responses to unexpected events. But this transformation takes time, and not all airlines are moving at the same pace. Smaller carriers often lack the resources to implement cutting-edge technology systems, while larger airlines face the challenge of integrating new technology with existing operations that can't be shut down for upgrades. Industry experts predict elevated safety incidents will continue as airlines work through this transition. However, these incidents aren't necessarily dangerous. They are the result of highly effective precautions.